Okay, so when it comes to polynomials, there's a lot of things that go on with polynomials. There's multiplying, there's adding, there's subtracting, there's dividing, there's roots, there's a lot of things. And so because it's such a big chapter, the 19 questions here, there's 19 for a reason. They're all very important. So I'll talk you through each and every one of them. And then I'll also have a calculator portion. If a calculator portion applies to any of this, I'm not sure how much of it would apply to it, but anything that does apply to a calculator, I will do that on there. So let's get into some of these. So I'm going to use my scratch pad for most of this. So number one is negative 2 x to the fourth y to the second times 6y minus xy. So this is just simple distributing. You just have to make sure you combine your exponents really, really carefully. So you're taking all of this. This is all one term here, the negative 2x to the fourth y to the second, and you're multiplying it with 6y at first. That's our distributing. So negative 2 times 6 is negative 12. X to the fourth, I'm not multiplying any other x's with it, so it still remains x to the fourth. And then y to the second is combining with a y. That makes y to the third, because 2 y's here and a y there makes 3 of them in total. And then you distribute it to the next group, which is negative xy. So we're going to take this and multiply it to negative xy. So first and foremost, think of this as a negative 1. So a negative 2 times a negative 1 is going to make that plus 2. X to the fourth and another x makes an x to the fifth, and then a y to the second with another y makes a y to the third. And so that is your work. That is your answer for number 1. Number 2 is 3x squared minus 6 plus 2x squared plus 5. So notice you're adding, and anytime you got a plus sign or minus sign in the middle here, just combine like terms. You do not have to change anything with the exponents. You only change exponents when you're multiplying terms like we did in the last one. But I'm not multiplying these, I'm adding these. 3 plus 2 is 5, so we'll have 5 x squared, okay, because they're the x squared terms. And then you've got the other like terms, negative 6 plus 5. Negative 6 plus 5 is negative 1, so it's 5x squared minus 1 as your answer. Number 3, another multiplying one, 2x minus 1 times x plus 3. So 2 options. You can FOIL it, which is what I would do, or you can make a little table, 2x and negative 1 for the 2x minus 1, and then x and 3 for the x plus 3. And you can solve it either way because you are multiplying, but I'm just going to resort to foiling because it is only 2 terms by 2 terms, and that's going to be a little, I guess, more familiar. So 2x times x makes 2x squared. And then 2x times 3, 2 times 3 makes 6, so that's going to be 6x. Negative 1 times x is just negative 1x, and negative 1 times 3 is negative 3. So just combine these terms in the middle, and you are good. 6 minus 1 will make 5x. So it'll be 2x squared plus 5x minus 3. Number 4. Another adding problem. Again, pay attention to the fact that it's got that plus sign. So 4x minus 3x squared minus 1 plus 3x squared plus x plus 5. So again, notice a plus sign. That means just find like terms, combine like terms. So a couple like terms to point out. I've got my x squared here. Now this is interesting. It's negative 3x squared plus 3x squared. And negative 3x squared plus 3x squared makes 0x squared. So there is no x squared in our answer. So it's either going to be option 2. It's got to be option 2, I guess. But let's see how the other things fall together. So other like terms, you have 4x plus x. So 4x plus x makes 5x. And then negative 1 plus 5. Negative 1 plus 5 is 4. So that'd be 5x plus 4. So it is option 2. So be careful. That one's kind of a funny one because the x squared's canceled. Number 5, subtraction. So not really that much harder, but you got to be careful. 5x minus 5x squared plus 11 minus 3x minus 2. So here's what I do. I immediately distribute this negative and then rewrite that so I don't even have to worry about subtraction anymore. I know it's minus 3x and I know it's plus 2. So now I'm just going to do basically normal combining of like terms. So there is no other x squared term, so I'm not going to change this. I'm going to leave that negative 5x squared there. I can combine my x terms, my 5x minus 3x. 5 minus 3 is going to make 2x. And then my last part, 11 plus 2 is 13. So negative 5x squared plus 2x plus 13. Number 6. Number 6 is a little more interesting because it is division. So it's kind of interesting. So the area of a rectangular shaped volleyball court. So let's kind of draw a picture as to what this is. The area of this court is 8x to the third plus 10x squared minus x minus 2. And the width is represented by 2x plus 1. So what's the length of the volleyball court? How long is this side? Well, here's the thing I know. I know that the area, which is what this is the length times width. That whatever this is times this would equal that. Well, of course, I'm going the opposite direction. So if I want to find L, what I'm going to do is I'm going to take my area and I'm going to divide it by my 2x plus 1. So it is a division problem, but it says it as a word problem. So we're taking our 8x to the third plus 10x squared minus x minus 2 and dividing it by the 2x plus 1. So remember, when it comes to division, you got 4 steps. You got step 1, which is divide. Step 2, which is multiply. 3, which is subtract. And 4 is bring down. So I'll explain all those steps as we work this out here. So divide. When you divide, it's always the first term on the inside divided by the first term on the outside. So we're doing 8x to the third, and we're dividing it by 2x. Now 8 divided by 2 is 4, and x to the third divided by x makes x squared. So what we're going to do is we're going to take that result, 4x squared, we're going to put it on top because that's part of my answer. And you can see all the answer choices have that 4x squared, so we know we're on the right track. So step 2 is multiply. I'm going to take the result that I just got, the 4x to the second, 4x squared, and I'm going to multiply it to, take that and multiply it to my polynomial up front. So 4x squared times the 2x plus 1. Now 4x squared times 2x is 4 times 2 is going to make 8, and x to the second times x makes x to the third. And then 4x squared times 1, 4 times 1 is still 4x squared. So I'm putting that underneath those corresponding like terms because step 3 is subtract. So I'm going to subtract these terms from each other. So the first ones are always going to cancel. 8 minus 8 is going to go away and disappear. That always happens. The second group, however, you got to be careful because it was plus 4x squared, but you are subtracting. So do the opposite of whatever the sign is. So it was plus, change it to minus. 10 minus 4 is going to be 6x squared. And do that every time. Every time you subtract, you should always change that sign. If it's plus, do minus. If it was minus, then do plus. Okay, that one was plus, so I changed it to minus. Step 4 is to bring down the next term. So negative x, I'm going to bring that down. And now we repeat back to the beginning, divide. And we divide the same thing I did before. The first term on my inside, which is now 6x squared, divided by the first term on the outside. So we're doing 6x squared, and we're dividing it by 2x. 6 divided by 2 is 3, and x squared divided by x is x. So I'm going to put that 3x back on top with the other answer, 4x squared. So I can see my progress here a little bit. I know it's either option 2 or option 4 based on what I have at this point. So step 2 is multiply. Take the result we just got, the 3x, and multiply it with 2x plus 1. So the 3x, multiply it with 2x plus 1. So 3x times 2x is going to be 6x squared. And then 3x times 1 is just 3x. So when I subtract, the first terms are always going to cancel. And remember, that's a plus sign, but I'm going to change it to minus. -1 minus 3 makes -4x. And then I bring down my -2. And so now one more time, divide this first term, -4x, divided by the first term on the outside, which is still 2x. -4 divided by 2 is -2, and the x's are going to cancel. So that -2 is going to be the result that goes up on top. And at this point, it is multiple choice, so I'm not even going to bother finishing the problem. I already can see my answer written down, right? Option 4. Now, number 7 is not multiple choice, but it is something we can use synthetic division on. So it's only asking what is the remainder. So it's not asking for me to use the whole division thing, but what is the remainder? So if you're dividing by x plus 5, then my a or x value is going to be -5, because it says dividing by x plus 5. So the opposite of this will be my a value, so it's -5. The polynomial I'm dividing it from is 3x to the 4th, so 3 for the 3x to the 4th, plus 2x to the 3rd, so 2 for 2x to the 3rd. And then it doesn't have an x squared term, it doesn't have an x term, but then it has plus 6 at the end. So I have to put a 0 in for the x squared, a 0 in for the x, and then a 6 at the end. Okay, so that shows me the x to the 4th, the x to the 3rd, the x squared, x, and then 6 altogether. So be careful, make sure you fill in the zeros. Now, synthetic division, you just bring down the first term, bring down this 3, and then start multiplying. 3 times my a value, which is -5. 3 times -5 is -15. 2 minus 15 is -13. Multiplying that is positive 65, and 0 plus 65 is 65. 65 times -5. Oh, man, I'm going to need a calculator. Hold on. 65 is -325. 0 minus 325 is still -325. And then multiplying that with 5 again is positive 1,625. This looks kind of big, and you're not wrong. It is just that weird. And then you're adding those up. 6 plus 1625 is 1,631, I believe. So it is a big number. Unusually so, but it's a weird question on a weird test. So it works the same way you know how to work it. It's just the answer looked a little odd. All right, so some of these questions you don't have to really work out. You just have to know the connections. So for the next few problems, please listen carefully as I try to explain to the best of my ability how to know what's going on. So number 8, if a polynomial, let me pull it up on my screen, I guess. I'm reading it off a piece of paper. So number 8, if a polynomial is divided by x plus 4, the quotient, so the answer was x squared minus 7x plus 34 minus 144 over x plus 4. Which of the following must be true? So here's what I try to remind you guys of. If you were to use synthetic division on something prior to this, this would mean that the x value or a value is -4, right? Because you're dividing it by x plus 4. And we talk about how we change the sign a lot, right? And I always also mention that the remainder, which as you can see in this problem is a -144 because of that little minus sign there. The remainder is your y value. Remainder is your y value. It's always your y value for that corresponding x value. So the answer to this is option 2, because option 2 says, hey, if x is -4, your y value is going to be -144. That's the connection you need to make a lot of the time, is that this, pull the x value from that, the remainder is your y value. That principle is going to be thrown throughout this a lot. So we'll use that. We'll come back to that and make a note of that for other problems as well. So number 9, I think, refers to that as well. If the binomial x minus 7 is a factor, so remember, x minus 7 means that x equals +7, is a factor, then which statement must be true? Now, if it's a factor, remember we talked about its remainder being equal to 0, which means its y value being equal to 0, because the remainder is the y value. So this tells me that option 2 is the answer here, because that says, hey, x is a +7, and the y value or remainder must be 0. Okay. Number 10. So the polynomial, yada yada, is given. Which conclusion is valid if p of 1, so this says x equals 1, or you can think of this as x minus 1, as the binomial it came from, is 5. That tells me that the y value is 5, or you can remember the y is the same as the remainder, or the remainder is 5. So I'm looking for anything that says that in my answer choices. So option 1, x minus 1 is a factor. Now, x minus 1 is something I pointed out, but it is not a factor, because for it to be a factor, the y would have to be 0. The y is 5 in this case, so it's not option 1. It's not option 2 either. Here's option 3, though, is our answer, because we talked about x equaling 1, which means x minus 1 is our binomial, and the remainder is 5, because the y value is 5. So option 3 would be the correct answer. So number 11, again, goes back to that whole idea that we were just talking about. So we'll try it again. The table below shows ordered pairs that belong to a polynomial function. Okay, if f of x is a cubic polynomial, which conclusion is valid? So it says x minus 1 must be a factor, x plus 1 must be a factor. F of x divided by x plus 1 has a remainder of 14, and f of x divided by x plus 2 has a remainder of 1. So this right here, option 1 is talking about that binomial, which means x equaling a +1. Now, it says must be a factor. So if it's a factor, then the y value there would be 0. So on my table, you can see, hey, I've got x equal to 1, y equal to 0. And that's exactly what option 1 is pointing out. So option 1 is probably our answer. But let me explain the other options as well so you can get a fuller understanding. So option 2, this is referring to when x equals -1. And is a factor means the remainder or y value would have to be 0. So -1, the remainder is not 0, it's -14. So option 2 is incorrect. Option 2 wouldn't work, wouldn't make sense here, because if it were to work, then the -14 would have to be a 0. Option 3 says okay, I was thinking this was right for a second, but it's not. When you're dividing by x plus 1, which means yet again, you're looking at x equal to a -1, the remainder is 14. Now, that means that the y value is 14. So if you go to -1, the y value is not 14, it's -14. So that's why I almost thought for a second it was right, but I noticed the negatives. So that would be right if it was a +14 instead of a negative, but it's not. Or if they wrote -14 down here, it would have been right. And then the last one, x dividing by x plus 2, that's referring to x equaling -2, and there isn't even an x equals -2 in the table up here. So we can't justify that at all with our table. So option 1 is definitely our answer. So make the connection between the binomials and what the x value really is for them. And of course, the remainder being the same thing as the y value as well. Number 12, what are the x-intercepts of the function? So basically, number 12 is just saying, hey, it's already factored. What makes all of these equal to 0? So you don't have to overthink it. You've got 3 groups. You have x, you just set that x equal to 0. You've got x minus 4, you just set that equal to 0. And you've got x minus 2, and you set that equal to 0. And you solve each of them, and you get your x values. So you'll have 3 numbers there for your answer. So we've talked about that one before. What are the zeros of the given graph? So again, all you're looking at is the x-axis. Let me zoom in a little bit. Where the graph crosses the x-axis. So the graph here crosses the x-axis there, there, and there 3 times. So those three x-intercepts are your solution. So pick the answer that matches with those 3. Number 14 is the exact same thing. So remember, you're not focused on the y-intercept at all. You're only focused on x-intercept. So here, 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 and here. Those are the only ones that it's asking you about. So pick the answer that talks about those. It's not important, the y-axis or the y-intercept. That's irrelevant. It only wants the ones on the x-axis. Okay. Number 15, well, what I just said in the last problem is the answer to this. The solution zeros are not where it crosses the y-axis, but where it crosses the x-axis. Number 16. This is how I would work it out. So let me pull up my sketchpad. So zeros are 1 and -3. So this tells me that my answers are x equals 1 and x equals -3. It wants me to use them to find the actual quadratic or equation they came from. So here's what I'm going to do. I'm going to reverse engineer it. Now, if x equals 1, then the factor it came from was x minus 1. And if x equals -3, then the factor it came from is x plus 3. Right? Because if you set those equal to 0, these are the answers you would get. So I'm working backwards here. I'm reverse engineering this problem. So I know those are the factors because I already knew these were the answers. So what I'm going to do is I'm just going to FOIL this together and get my equation. X times x makes x squared. X times 3 makes 3x. -1 times x. And then -1 times 3. So you combine these 2 in the middle, 3 minus 1 makes 2x, and you have your answer. So working backwards is sometimes smarter than trying to factor all 4 different answers and trying to work them out, or graphing all 4 answers. I think just working backwards, like I did, makes a lot of sense and is faster. So again, number 17 is asking about where it crosses the x-axis. I think it's pretty obvious. If you look at that, where it crosses the x-axis. Number 18, we're going to factor it. So which is a 0 of the function. So I'm just going to factor it. So we have 2x squared minus x minus 3. 2x squared minus x minus 3. So to factor this, I'm going to use product and sum. So a times c. A is 2 and c is -3. 2 times -3 is -6. And then b, which goes on the bottom, b is -1. So I'm looking for 2 numbers that multiply to -6 and add to -1. And so those 2 numbers would be a -3 and a +2. Now, no shortcut here because a is 2 and not 1. If a was 1, then my factors would be x minus 3 and x plus 2. But I can't do that here since a is not 1. I'm going to use these as x terms, and they're going to replace that middle x term. So we're still going to have 2x squared. And we're still going to have the -3 at the end. But in between, I'm going to put these as x terms. -3x plus 2x. All right. That's replacing the x term I had originally up there. So now I'm creating 4-term polynomial in which I factor by grouping. So I'm going to group these terms together, group those terms together, and then factor by GCF. So first term has an x in common, so I'll take that out. The second group has nothing in common, so I'm not going to take anything out. And I've got the common group of 2x minus 3. And then I've got x plus 1 on the as your GCF part, so as the other binomial. So when you set them equal to 0, you get this one equal to -1. And if you take 2x minus 3 equal to 0, you'll get, I believe, 3/2. But I'll let you work that out to confirm. Okay, but I think I helped you for most of the problem through factoring here. Number 19, and finally, is identify 1, 0 for the given polynomial. So there's 3 different options you could give, but you only need to give 1. You need to figure out, hey, if you want to use 2x could equal 0, so you can solve that one and get that answer. You can use x plus 2 equal to 0. You can solve that and get that answer. And you can use x minus 3 equal to 0, solve that and get that answer. Now, it's squared, which means there's just 2 of them, but there's no reason to solve x minus 3 equal to 0 twice because they're both going to be the exact same thing. So any one of those answers that you get would work for number 19. Okay, that's going to do it for this one. I don't know if I'll have a calculator version of this or not. If there will be, I don't know. We'll find out. But that's going to cover it. So I'll see you, if you're an honors student, I'll see you in the rational expressions. If not, for the rest of you, good luck on your exam. Please let me know how I can be of any more help. If you're still feeling weak on anything, let me know, and I'll try to find some stuff for you to practice just so we can up our exam grades. No one's exempt from our exam, so remember, study and do the best you can. All right, I'll see you guys later.